All right, so now we're going to be looking at what a solution is. Okay, so a solution is a homogeneous mixture or consisting of ions or molecules. Okay, and a solvent is a major component of a solution, while a solute is a minor component of a solution. Okay, so for example, when you have sugar that you dissolve into a glass of water, we will say that the water is the solvent while the sugar is the solute. How do you know which one is the solvent and which one is the solute? The solvent is usually the liquid or is usually the substance that is in a greater amount, while the solute is the usually the component that is in a smaller amount. Okay. So now, if let's say you keep adding sugar to your glass of water, do you think it is going to keep dissolving infinitely? The answer is no. If you keep adding the sugar, at one point, what you will realize is that some of the sugar is going to start settling at the bottom of the glass. Okay, so it will start settling at the bottom of the glass, and when it does that, what you will see is that we now describe that the solution is said to be saturated. Okay, we say the solution is said to be saturated. All right, so a solution that is concentrated, right? Let's talk about the term concentration. A measure is a measure of the amount of solute that is dissolved in a solution. Okay, so if you have a lot of sugar in a very small glass of water, we will say it's very concentrated. And so let's say you have a very tiny portion of sugar in a very big glass of water, we'll say that is a solution that is dilute. So the way we find out concentration is to divide the amount of solute, the mass of the solute divided by what? Divided by uh, either we can say is divided by the volume of the solution or divided by the mass in kilogram of the solution. So depending on the type of concentration. Okay. So when we say that a solution is concentrated, what we mean here is that we have more solute or we have a very large amount of solute in a very comparably small amount of solution or solvent. Okay. Why a solution that's said to be dilute is one in which you have a lot of solvent, right, compared to the solute. Now, let's talk again about the word mole. Again, we've talked about the Avogadro's number in a previous unit where we said it's a very large number and it's 6.02 times 10 to the 23rd. And this number is also, we call it the Avogadro number, and it's also, we sometimes refer to it also as the mole, right? Because one mole of a substance contains this number of particles, and it's also the Avogadro's number. Okay. So one mole of a substance, okay, one mole of a substance is usually going to be the is going usually going to weigh the mass of what we call the atomic mass. For example, for carbon, carbon has one mole of carbon weighs 12 grams, one mole of oxygen molecules weighs 32 grams, and one mole of a carbon dioxide molecule weighs 44 grams. One mole of a sucrose molecule, which is sugar, weighs 342 grams. Okay. So now we have a solution right here. So remember volume? Volume is measured in what? In liters. Okay. So concentration here, if we want to find the concentration, what we're going to do is that we take 1 mole of sucrose, which is equal to what? 342 grams. And 342 grams of sucrose contains what? 6.02 times 10 to the 23rd molecules of sucrose. Okay. So what we are going to say here is that the molar mass or the mass of 1 mole of sucrose is 342 grams per mole. Okay. Now, let's check this out. If you do have water, if it has a formula mass of 18 grams, how many moles of water are present in 18 grams of water? So the only thing you need to do is, if the formula mass is 18, then it means that 18 grams of water contains 1 mole of water. Okay. So how many grams of water are present in 2 moles? How many grams of water are present in 2 moles of water? So what you just need to do is 1 mole of water is 18 grams. So 2 moles of water is going to be 2 times 18, okay, which is 36 grams. Now let's talk about molarity. Molarity is a specific type of concentration. And so a unit of concentration expressed in moles of solute per liter of solution. Okay, so if you want to calculate the molarity, we say it's the number of moles of solute divided by the liters of solution. Okay. Another form of concentration is part per million, or we call it ppm. So you probably see this somewhere in real life where they're talking about 11 ppm or 200 ppm. All of that means part per million. So it's a unit of concentration expressed in milligrams of solute in liters of solution. Okay. So 1 part per million is 1 part of solute divided by 1 million part of solution, which in other words is 1 milligram of solute divided by 1 liter of the solution. Okay. So now let's talk about what we call solubility. So it's the ability of a solute to dissolve in a solvent. So the ability of a solute to dissolve in a solvent is what we call the solubility. And so we can actually see a graph of the solubility of various substances. Okay. So on this axis, we have temperature, and on this axis, we have what? We have the solubility or the grams of the solute. So if you look at this substance right here, if you look at the graph is increasing. So what that means is that the solubility of this substance is increasing as the temperature increases. Okay. But if you take this other one like sodium chloride, the graph is pretty straight. And what this one means is that the solubility remains pretty constant as temperature increases. Remember that as you go in this direction, the temperature is increasing. Okay. Now, you have this term called precipitate. What is a precipitate? A solute that comes out of a solution. Okay. So as I was taking an example of a sugar solution. So let's say you keep adding sugar to a solution. At one point, you will see that sugar settling at the bottom like that. Okay. And that usually happens when a solution becomes saturated. So the amount of oxygen dissolved in water in the waters of the Arctic Ocean is greater, about equal to or less than the amount of oxygen dissolved in warm tropical waters. You have to choose which one it is, but it is greater than. Because the solubility of oxygen in water decreases with increasing temperature. As a consequence, cold polar oceans tend to be more fertile than warmer tropical waters. Okay. By mass, water is 88.88% oxygen. So why can't we breathe water? What a good question. The hint here is, what is the elemental formula of oxygen we breathe and the chemical formula of water? So those two formulas are different, okay? So we're going to end here, and we're going to do, for this section, yes, we'll end here.